Our planet has not always been the familiar blue and white marble we know today. Its history is a grand saga of change, a dance between fire and ice that has spanned billions of years. Earth formed about 4.5 billion years ago from the dust and gas surrounding the young sun. Initially, it was a molten mass, bombarded by asteroids and comets. As it cooled, a solid crust formed, and volcanic activity released gases, creating a primitive atmosphere. Water vapor condensed to form the first oceans. Life began in these oceans around 3.8 billion years ago with simple, single-celled organisms. These early life forms, like stromatolites, played a crucial role in shaping our atmosphere. About 2.5 billion years ago, cyanobacteria started producing oxygen through photosynthesis, leading to the Great Oxygenation Event, which dramatically altered the atmosphere and allowed for more complex life forms to evolve. Earth has experienced several major glaciations, including the snowball Earth periods, around 700 million years ago, when ice sheets may have covered the entire planet. The Cambrian explosion, around 541 million years ago, saw a rapid diversification of life, with many major groups of animals appearing in the fossil record. Life eventually moved on to land, with the first plants appearing around 470 million years ago, followed by the first forests and terrestrial ecosystems. The Permian-Triassic extinction event, about 252 million years ago, was the most severe extinction event in Earth's history, wiping out around 96% of marine species and 70% of terrestrial species. The Mesozoic era, known as the Age of Dinosaurs, began after this extinction. Dinosaurs dominated the planet for over 160 million years, evolving into a wide variety of forms. The Cretaceous-Paleogene extinction event 66 million years ago was caused by an asteroid impact, leading to the extinction of the dinosaurs and many other species. This event paved the way for the rise of mammals, which diversified and evolved into the wide range of species we see today. The Quaternary period, which began around 2.6 million years ago, has been marked by repeated glacial cycles, with ice sheets advancing and retreating across the continents. During this time, early humans evolved and spread across the globe, adapting to a wide range of environments. We are currently living in what scientists call an interglacial period, a warmer spell within a much larger ice age that has defined the last few million years. This current warm phase, which allowed human civilization to flourish, began roughly 12,000 years ago. But this is just a brief moment in geological time. Looking back, we find that Earth has experienced cycles of extreme cold and warmth, with vast ice sheets advancing and retreating across the continents like a slow, rhythmic breath. The last time our world was significantly warmer than it is at present was about 130,000 years ago, during the previous interglacial period. Temperatures then were around 2 degrees Celsius higher than they were before the Industrial Revolution. As a result, sea levels were a staggering 6 to 9 meters higher than they are today. This tells us that even a seemingly small change in global temperature can have a dramatic impact on the planet's ice and oceans. It provides a crucial warning from the past, a natural experiment that demonstrates the sensitivity of our world's frozen water to sustained warmth, a lesson etched into ancient coastlines across the globe. To find a time when Earth was completely free of ice, we must travel much further back to the age of the dinosaurs. Between 166 million years ago, during the Cretaceous period, the planet was a very different place. Global temperatures were much higher, and there were no polar ice caps. The continent we now know as Antarctica, a desolate expanse of ice, was then a dense subtropical forest. It would have looked much like New Zealand's North Island does today, teeming with life. Dinosaurs, including mighty sauropods and armoured ankylosaurs, wandered through its verdant landscapes under a sun that never set for months on end. This ice-free world had consequences for the oceans. With no water locked away in massive ice sheets, sea levels were about 200 meters higher than they are in our time. Vast inland seas covered areas that are now the heartlands of continents. This ancient past shows us the planet's capacity for radical transformation. It is a stark reminder that the world we inhabit, with its familiar coastlines and frozen poles, is not a permanent state, but a fleeting chapter in Earth's long and ever-changing story. The ice we see today is a legacy of a cooler climate, one that is now changing once again. The cryosphere is the collective term for all the frozen water on our planet, a vast interconnected system of ice and snow that stretches from the highest mountain peaks to the deepest polar basins. It is a world both ancient and dynamic, shaped by millennia of shifting climates and geological forces. At its heart lie the colossal ice sheets of Antarctica and Greenland, immense slabs of ancient ice that have accumulated over millions of years. These ice sheets are formed as layer upon layer of snowfalls, compresses, and recrystallizes, gradually transforming into dense blue ice that can be thousands of meters thick. Beyond the polar giants, countless mountain glaciers snake down valleys across every continent except Australia. These glaciers are born high in the mountains, where snowfall exceeds melting year after year. Over time, gravity pulls the compacted snow downhill, carving out dramatic landscapes and feeding rivers far below. The cryosphere also includes the vast expanses of sea ice that form and melt with the seasons, floating atop the polar oceans. In winter, sea ice can double the size of the polar regions, while in summer, much of it retreats, exposing dark ocean water that absorbs sunlight. Seasonal snow cover, meanwhile, blankets huge swathes of land in both polar and temperate regions, acting as a temporary but vital part of the frozen world. Beneath the surface, permafrost, ground that remains frozen for at least 2 consecutive years, sprawls across the Arctic tundra and high mountain plateaus. This hidden reservoir locks away ancient plant material, greenhouse gases, and even the remains of prehistoric animals, preserving a frozen archive of Earth's past. These frozen domains are not just passive features of the landscape. They play a critical role in regulating our planet's climate, acting as Earth's natural thermostat. By storing the vast majority of the planet's fresh water, they control the flow of rivers, sustain ecosystems, and buffer the impacts of drought and heat. The cryosphere's bright, reflective surfaces act like giant mirrors, bouncing sunlight back into space, a phenomenon known as the albedo effect. This helps keep the planet cool, especially in the polar regions where the sun's rays are weakest. The immense mass and dazzling whiteness of ice sheets and glaciers are fundamental to the global climate system. They influence atmospheric circulation, ocean currents, and even the distribution of heat around the globe, creating feedback loops that can either stabilize or destabilize Earth's climate. The Antarctic ice sheet is the undisputed giant of the cryosphere. Covering an area larger than the United States and Mexico combined, it is a continent of ice that has persisted for over 30 million years. In some places, the Antarctic ice is nearly 5 kilometers thick, so massive that its weight depresses the land beneath it. The ice sheet's formation is a slow, relentless process, with snow accumulating and compacting over countless generations. This single immense ice sheet holds an astonishing 60% of all the fresh water on Earth. Its frozen reserves are so vast that, if melted, they would raise global sea levels by nearly 60 meters. The scale of Antarctica's ice is almost beyond human comprehension. Standing at its edge, one is confronted by a wall of ice that stretches to the horizon, a frozen fortress that has withstood the test of time. If this ice were to melt, the consequences would be catastrophic. The Antarctic ice sheet contains the largest potential contribution to sea level rise, threatening coastal cities and low-lying nations around the world. Antarctica is the coldest, driest, and highest continent on Earth, a polar desert where blizzards rage and temperatures can plunge below -80 degrees Celsius. Its isolation and extreme conditions make it a unique laboratory for studying Earth's climate history. Yet, despite its remoteness, Antarctica's fate is intricately linked to the industrialized world thousands of miles away. Greenhouse gas emissions and global warming are melting its edges, sending ripples through the global climate system. In the northern hemisphere, the Greenland ice sheet is the second largest body of ice. It too is a relic of a colder past, formed by the relentless accumulation and compression of snow over more than 100,000 years. While much smaller than Antarctica, Greenland's ice is still formidable. Its surface is riddled with crevasses and meltwater channels, evidence of the constant battle between freezing and thawing. Greenland covers an area roughly 3 times the size of Texas, its icy dome rising above the Arctic Circle and dominating the North Atlantic. It holds another 8 to 10% of the world's fresh water, locked away in layers of snow and ice that have built up over millennia. Scientists study ice cores drilled deep into Greenland's ice, revealing a detailed record of past climates, volcanic eruptions, and atmospheric changes. Each layer is a time capsule, preserving the story of Earth's changing environment. Today, Greenland's meltwater is a major contributor to rising sea levels. As temperatures climb, rivers of meltwater carve through the ice, accelerating its loss and sending fresh water into the salty ocean. Scientists monitor these changes closely, using satellites, drones, and field stations to track the pace and severity of ice loss. Greenland has become a key indicator of how quickly our climate is changing. Beyond the great ice sheets, the world is dotted with thousands of smaller glaciers and ice caps, from the Himalayas to the Andes, the Alps to the Rockies. Together, these frozen reservoirs store over 30 million gigatons of water, enough to reshape coastlines and alter weather patterns if released. The ice itself is a marvel of nature. Ancient layers, compressed and purified over centuries, hold tiny bubbles of prehistoric air, offering scientists a direct window into Earth's atmospheric history. These glaciers act as natural water towers, slowly releasing meltwater that feeds rivers and sustains billions of people, especially during dry seasons. In regions like the Himalayas and Andes, entire communities depend on this steady flow for drinking water, agriculture, and energy. The health of the cryosphere is not just a polar concern, it is a global issue, intimately connected to water security, climate stability, and the very shape of our world. As Earth's frozen reservoirs change, so too does the future of humanity and the planet we call home. If all of this ice, from the polar giants to the smallest mountain glacier, were to melt, the most immediate and dramatic consequence would be a catastrophic rise in global sea levels. This would not be a gradual process, but a rapid and relentless transformation of our planet's geography. Scientists estimate that the complete melting of all land-based ice would release enough water to raise the average sea level by approximately 71 meters, or about 233 feet. This staggering rise would be composed of roughly 58 meters from Antarctica, 8 meters from Greenland, and the rest from all the other glaciers combined. Antarctica alone holds about 26.5 million cubic kilometers of ice, and its melting would contribute the most to sea level rise. Greenland, with its 2.85 million cubic kilometers of ice, would also play a significant role. The remaining glaciers, scattered across the globe, would add the final meters to this global deluge. Such a rise would not just redraw coastlines, it would utterly transform the face of our planet, submerging vast areas of land where hundreds of millions of people currently live and work. Coastal cities, farmlands, and entire regions would be lost to the encroaching sea. In the United States, the geography would become unrecognizable. The entire state of Florida would vanish beneath the waves, along with much of the Atlantic and Gulf coasts. Major cities like Miami, New Orleans, and Houston would be completely submerged. The loss of Florida would mean the disappearance of a state that is home to over 21 million people. The Gulf Coast, known for its vital oil refineries and ports, would be devastated, leading to economic turmoil. Great cities like New York, Boston, Washington, D.C., and New Orleans would be completely inundated, their iconic landmarks becoming nothing more than artificial reefs for a new marine ecosystem. The Statue of Liberty, a symbol of freedom, would stand submerged, a poignant reminder of the past. On the West Coast, the story would be similar. San Diego and much of Los Angeles would be lost, and California's Central Valley would flood, turning San Francisco into a cluster of islands. The agricultural heartland of the Central Valley, which supplies a significant portion of the nation's produce, would be underwater. The nation's map would be rewritten by the encroaching sea, displacing tens of millions of people. Mass migrations would become the norm as people flee the rising waters, leading to overcrowded inland cities and strained resources. Across the Atlantic, Europe would face a similar fate. The Netherlands, a country famous for its centuries-long battle with the sea, would be almost entirely lost, as would the whole of Denmark. Nearly half of Belgium would disappear. The Netherlands, with its intricate system of dikes and polders, would be overwhelmed. The country's low-lying topography makes it exceptionally vulnerable, and the loss of this land would displace millions. Belgium, too, would see nearly half of its territory submerged, including major cities like Antwerp and Brussels. The economic and cultural impact would be profound. The United Kingdom would be drastically altered, with London, a city built on a tidal river, completely submerged. The Thames Barrier, designed to protect the city from flooding, would be rendered useless against such a monumental rise in sea levels. The low-lying plains of northern Germany and Poland would become part of an expanded Baltic Sea. Cities like Hamburg and Gdansk would be underwater, leading to significant loss of life and heritage. The historic and cultural heartlands of Venice and other Mediterranean coastal cities would be lost forever, their art and architecture consigned to the depths of a swollen sea. The loss of Venice, a UNESCO World Heritage Site, would be a cultural catastrophe. The impact on Asia would be even more profound, affecting a larger portion of the global population. The densely populated coastal plains of China would be flooded, submerging megacities like Beijing and Shanghai. In China, the economic hubs of Shanghai and Beijing would be underwater, leading to a massive displacement of people and a significant economic downturn. The loss of these cities would have global repercussions. In Japan, Tokyo and other coastal metropolises would be underwater. The loss of Tokyo, one of the world's most populous cities, would be a disaster of unprecedented scale. The entire nation of Bangladesh, home to over 170 million people, would be wiped off the map, creating a refugee crisis of unimaginable scale. The densely populated Delta region would be completely submerged. The Black and Caspian Seas, currently separated by a vast landmass, would swell and merge into one enormous inland ocean. This new body of water would cover parts of Russia, Kazakhstan, and other surrounding countries. The world's population centers would be forced to retreat, abandoning centuries of development. The mass migration inland would lead to overcrowded cities, strained resources, and potential conflicts over land and water. The melting of Earth's ice would not just reshape our coastlines, it would redefine human civilization itself. The transformation of our world would not be limited to individual cities or nations. It would be a sweeping, all-encompassing event, reshaping the very face of every continent on Earth. The melting of all the planet's ice would trigger a cascade of ecological, geological, and human upheavals, the likes of which humanity has never witnessed. Entire continents would see their coastlines redrawn, their shapes fundamentally altered as the oceans surged hundreds of kilometers inland. Ancient mountain ranges would become new shorelines, and vast lowlands would vanish beneath the waves. Africa, with its higher average elevation, would lose less total land area than other continents, but the changes would still be profound. The Sahara Desert would edge closer to the new Mediterranean coastline, and the highlands of Ethiopia and Kenya would become vital refuges for both people and wildlife. Coastal populations would be devastated. Mangrove forests and wetlands, crucial for biodiversity and storm protection, would be drowned, leading to the collapse of local fisheries and the loss of critical habitats for countless species. In Egypt, the ancient city of Alexandria and the bustling modern capital of Cairo would be consumed by the Mediterranean Sea, erasing millennia of history and culture. The Sphinx and the pyramids, if not relocated, would stand at the edge of a new sea or be lost entirely. The Nile Delta, once the breadbasket of the region, would be inundated, destroying fertile farmland and displacing millions who depend on its rich soils for survival. Saltwater intrusion would poison the remaining arable land, making agriculture nearly impossible. Other major coastal cities like Lagos in Nigeria and Dakar in Senegal would vanish beneath the rising Atlantic, forcing the migration of tens of millions of people inland. The loss of these economic hubs would cripple regional economies and spark humanitarian crises. In South America, the Amazon basin would be dramatically transformed. The world's largest rainforest would be partially submerged, with saltwater pushing far up the Amazon and Paraguay rivers, turning vast stretches of jungle into brackish wetlands. The rising Atlantic would push saltwater deep into the heart of the continent, devastating freshwater ecosystems. Countless species of fish, amphibians, and plants would face extinction as their habitats are transformed or destroyed. Indigenous communities, whose lives are intricately tied to the rhythms of the river and forest, would be forced to abandon their ancestral lands. The Amazon, once a lush green artery, would become a vast inland sea, its ecological balance shattered. The coastal cities of Buenos Aires in Argentina and Montevideo in Uruguay would disappear beneath the waves of a newly formed Atlantic Gulf, erasing centuries of urban development and culture. South America's economic and population centers, heavily concentrated along its coasts, would be devastated. Ports, factories, and entire neighborhoods would be lost, triggering mass unemployment and social upheaval. Survivors would be forced to migrate to the higher ground of the Andes and the Brazilian highlands, leading to overcrowding, resource shortages, and fierce competition for arable land and clean water. Australia, a continent known for its arid interior, would gain a new feature, a massive inland sea. The low-lying basins at the heart of the continent would fill with seawater, altering weather patterns and creating new, unpredictable ecosystems. The rising oceans would pour into the Lake Eyre Basin and other depressions, creating a new coastline that would cut deep into the Australian heartland. Once dry salt flats would become brackish lakes, attracting new species but also threatening existing ones. The boundaries between desert and sea would blur, and the outback would be transformed into a patchwork of islands and peninsulas. Unique Australian species, already under threat, would face new challenges as their habitats shrink or disappear. Most of the country's population, concentrated along the coast, would be forced to abandon their homes. The loss of cities like Sydney, Melbourne, and Perth would mark the end of Australia's most vibrant cultural and economic centres. Iconic landmarks would vanish beneath the waves, and the nation's identity as the land down under would be forever changed. The abandonment of the most developed and populated regions would leave behind ghost cities, their infrastructure decaying beneath the relentless advance of the sea. The iconic beaches and coastal communities that once defined Australia's image would be lost, replaced by eroded shorelines and new, unfamiliar landscapes. Wildlife would be forced to migrate or perish, and the delicate balance of coastal ecosystems would be upended. Ultimately, a total ice melt would create a water world, fundamentally different from the one we inhabit. New seas would stretch across continents, and the boundaries between land and ocean would be forever blurred. The total land area of our planet would shrink dramatically, with new coastlines often pressed against the slopes of ancient mountain ranges. Entire countries would vanish, their cultures and histories submerged. The political map would have to be completely redrawn, as nations are forced to redefine their borders and identities in a radically altered world. The disappearance of entire islands and low-lying nations would create millions of climate refugees, straining the resources and stability of the remaining habitable land. International cooperation and conflict would intensify as countries struggled to accommodate displaced populations and manage dwindling resources. The world's population would be squeezed into a much smaller area, leading to overcrowded cities, makeshift settlements, and fierce competition for food, water, and shelter. The pressure on the remaining land and resources would be immense, accelerating environmental degradation and threatening the survival of countless species, including our own. In this new world, the familiar outlines of our continents, so deeply ingrained in our collective memory, would exist only in history books and the fading stories of those who once lived by the sea. Now, the consequences of melting all Earth's ice extend far beyond rising seas and altered coastlines. The very structure of our planet, its crust, its rotation, and even its tectonic activity would be fundamentally transformed. The sheer mass of water currently locked up at the poles is immense, exerting a powerful downward force on the Earth's crust beneath. As this ice melts, trillions of tons of water would be redistributed from the polar regions towards the equator, dramatically altering the planet's mass balance. This massive shift in weight would have a tangible effect on the physics of our planet, specifically its rotation, but also on the very crust itself. Think of a figure skater spinning on the ice. When they pull their arms in, they spin faster. When they extend their arms, their spin slows down. In the same way, moving mass from the Earth's axis at the poles to its middle, around the equator, would increase the planet's moment of inertia, causing its rotation to slow down. This slowdown would not be dramatic enough to feel, but it would be measurable and significant. The melting of the Greenland ice sheet alone is predicted to lengthen our day by about 2 milliseconds. A total melt of all ice on Earth would increase the length of a day by at least several milliseconds more. While this might sound trivial, our modern technological society is built on incredibly precise timekeeping. Global positioning systems, or GPS, the backbone of modern navigation for everything from smartphones to commercial airliners, rely on atomic clocks synchronized to fractions of a second. A change in the Earth's rotation would require constant adjustments to these systems to prevent them from failing. Beyond slowing down, the Earth would also begin to wobble more on its axis. This phenomenon, known as polar motion, is the movement of the Earth's rotational axis relative to its crust. The redistribution of mass would alter the planet's balance, causing the spin axis to drift and wobble in new and unpredictable ways. This is not just a theoretical concept. Scientists have already detected a shift in the Earth's axis due to the melting that has occurred in recent decades. A complete melt would exacerbate this effect dramatically, pushing the geographic north and south poles to new locations. This axial shift could have profound implications for our climate and weather systems. The stability of the seasons is tied to the tilt of our planet's axis. A significant change could alter seasonal patterns, making them more extreme or less predictable. It could also disrupt major atmospheric and oceanic circulation patterns, such as the jet stream and the Gulf Stream, which are vital for regulating weather across the Northern Hemisphere. This could lead to more erratic and severe weather events, including prolonged droughts in some regions and unprecedented storms in others, creating a more chaotic and dangerous climate for everyone. But the story doesn't end with the atmosphere. The removal of such immense weight from the polar regions would trigger a process known as glacial isostatic adjustment. As the ice melts, the crust beneath, once pressed down by kilometers of ice, would begin to rebound and rise, a process that can take thousands of years. We have historical precedents for this. After the last ice age, Regions like Scandinavia and Canada experience significant uplift. Some areas have risen hundreds of meters since the ice retreated, reshaping coastlines and altering river systems. This rebound doesn't just lift the land, it can also reactivate ancient fault lines and increase tectonic activity. Scientists theorize that the redistribution of mass and the flexing of the crust could trigger earthquakes and even volcanic eruptions in regions previously considered stable. In fact, studies have linked the end of past ice ages to increased seismic and volcanic activity as the Earth's crust adjusted to the loss of glacial weight. Looking ahead, if all the ice on Earth were to melt, we could expect widespread crustal movement, increased earthquake risk in some areas, and the possible awakening of dormant volcanoes. Coastal regions might sink as the weight of new water presses down, while former ice-covered lands would continue to rise. The shifting of Earth's crust and the rebalancing of tectonic forces would reshape continents, alter ocean basins, and potentially redraw the map of our world over millennia. The melting of all Earth's ice would not just be a story of water and weather, but of a planet in motion, its crust, its axis, and its very bones, shifting in response to a new world order. Beneath the colossal ice sheets of Greenland and Antarctica lies a hidden world, one that has been sealed off from humanity for millions of years. This world is not just a barren expanse of rock and mountains, but a vast repository of untapped natural wealth, ranging from precious minerals and fossil fuels to ancient resilient forms of microbial life that have evolved in total isolation. For millennia, these resources have been locked away, inaccessible under kilometers of solid ice. The sheer thickness and remoteness of these ice sheets have acted as a natural vault, preserving not only geological riches, but also unique biological specimens and chemical compounds. An ice-free world would, for the first time in human history, expose these last untapped frontiers. As the ice recedes, the land beneath would be revealed, land that has never been touched by human hands and whose resources have never been exploited. Greenland, for instance, is already known to be a geological treasure trove. Its bedrock is rich in a variety of minerals, including gold, platinum, zinc, lead, and especially rare earth elements, materials that are critical for the production of high-tech electronics, renewable energy systems, and advanced military hardware. A 2023 survey by the European Union identified that the island holds significant deposits of 25 out of the 34 minerals deemed critical for modern industry. These include neodymium and dysprosium, essential for powerful magnets in wind turbines and electric vehicles, as well as cobalt and lithium for batteries, and tantalum for microelectronics. As the ice retreats, these vast mineral reserves would become accessible for mining and extraction. The economic implications are enormous. Greenland could become a major supplier of resources that are currently dominated by a handful of countries, potentially shifting the balance of global trade and technology. This could trigger a resource boom of unprecedented scale, turning Greenland into a new epicenter of global mining. The influx of investment, infrastructure, and labor could transform the island's economy, creating new cities and industries almost overnight. The potential wealth is staggering, enough to transform its economy and geopolitical standing. Greenland could become a key player in the global supply chain for green technologies, and its newfound resources could attract the attention of powerful nations and multinational corporations. However, this would also present immense challenges. The Arctic environment is harsh and unpredictable, with permafrost, extreme cold, and seasonal darkness complicating extraction efforts. The cost of building and maintaining infrastructure in such conditions would be immense, and the risk of environmental disasters, such as toxic runoff, oil spills, and habitat destruction, would be ever present. The newly exposed land would be a pristine and fragile environment, home to unique ecosystems that have evolved in isolation. Even small disturbances could have outsized impacts, threatening rare species and disrupting delicate ecological balances. Large-scale mining operations would inevitably cause significant environmental damage, raising difficult questions about how to balance economic opportunity with ecological preservation. In a world already grappling with the consequences of environmental change, the scars left by mining could persist for centuries, and the release of previously trapped greenhouse gases from disturbed permafrost could accelerate global warming even further. Antarctica, a continent currently protected by an international treaty that bans mineral and oil exploration, is also believed to hold vast reserves. The Antarctic Treaty, signed in 1959, has so far preserved the continent for scientific research and peace, but the lure of untapped resources could test the resolve of the international community. Geological surveys suggest the presence of a massive coal basin in the Transantarctic Mountains, as well as significant oil and natural gas deposits in offshore regions like the Ross Sea. These fossil fuels could be worth trillions of dollars, and their extraction would have profound economic and environmental consequences. If the Antarctic Treaty were to collapse in a future world desperate for resources, the continent could become the site of a frenzied scramble for fossil fuels and minerals. Nations would compete for territorial claims, and the resulting geopolitical tensions could reshape international relations for decades to come. This would pit nations against each other in a high-stakes competition for the last great resource prize on Earth, turning the pristine polar wilderness into an industrial landscape. The construction of refineries, pipelines, and ports would forever alter the face of Antarctica, and the risk of catastrophic oil spills or mining accidents would be ever present. This exposure of new resources is not just a future possibility, it is already beginning to happen on a smaller scale. As glaciers retreat, prospectors and companies are moving in to stake claims and begin extraction, often with little oversight or regulation. In Siberia, the melting of permafrost is revealing the perfectly preserved remains of woolly mammoths that died thousands of years ago. These remains are not only of scientific interest, providing clues about ancient ecosystems and climate, but also of commercial value. This has created a booming black market for so-called ethical ivory, with mammoth tusks fetching up to $100,000 each. The trade in ancient ivory is largely unregulated, raising concerns about the exploitation of newly exposed resources and the potential for criminal activity. In the Arctic, entrepreneurs are already bottling and selling melted glacier ice from places like Svalbard as a luxury product for $100 a bottle. This is just one example of the strange and sometimes absurd business opportunities that arise as the ice disappears. These niche economies are early signs of the strange and unpredictable business opportunities that will arise as our frozen world thaws. But the most intriguing discoveries may be biological. As the ice melts, scientists are finding ancient microbes, some dormant for millions of years, trapped in the ice and permafrost. These microorganisms could hold the key to new antibiotics, enzymes, or even biofuels, offering potential breakthroughs in medicine and industry. However, they also pose unknown risks, as some could be pathogenic or disrupt existing ecosystems if released. The scientific and economic potential of these hidden resources is vast, but so are the ethical and environmental dilemmas. As the ice melts, humanity will be forced to confront difficult choices about how to manage, exploit, and protect the last great frontiers on Earth. The rapid melting of the world's ice, especially in the Arctic and Antarctic, is not just an environmental crisis, it is fundamentally reshaping the geopolitical landscape of our planet. As glaciers retreat and sea ice vanishes, the boundaries of nations, the balance of power, and the very nature of international relations are being rewritten before our eyes. The Arctic, once locked in ice and largely inaccessible, has become the epicenter of a new era of international competition, often called the race for the Arctic. As the ice recedes, nations are scrambling to assert sovereignty over newly exposed waters and land, invoking the United Nations Convention on the law of the sea to extend their continental shelves and claim vast new territories. The opening of new shipping routes such as the Northern Sea Route along Russia's coast and the Northwest Passage through Canada is revolutionizing global trade. These passages can reduce travel time between Europe and Asia by weeks, slashing fuel costs and reshaping the world's logistics networks. According to the Center for Strategic and International Studies, the volume of Arctic shipping has already increased fivefold since 2013, and experts predict exponential growth as the ice continues to retreat. These new routes are not just economic boons, they are also flashpoints for conflict. The legal status of the Northwest Passage, for example, is hotly contested. Canada claims it as internal waters, while the United States and others insist it is an international strait. This disagreement has led to diplomatic standoffs and could escalate as the passage becomes more navigable. The 5 nations with Arctic coastlines, the United States, Russia, Canada, Denmark via Greenland, and Norway, are all racing to solidify their territorial claims. The Arctic Council, once a forum for peaceful cooperation, is now a stage for strategic maneuvering, with member states deploying legal, economic and military tools to secure their interests. Military activity in the region is surging. Russia has reopened dozens of Soviet-era bases and conducted large-scale exercises, while the United States is expanding its icebreaker fleet and increasing patrols. According to Dr. Katarzyna Zisk, an Arctic security expert, the militarization of the Arctic is no longer hypothetical. It's happening now, and it's accelerating. But the competition is not limited to shipping lanes or military posturing. Beneath the Arctic Ocean floor lie immense reserves of oil, natural gas, and rare minerals. The U.S. Geological Survey estimates that the region holds up to 13% of the world's undiscovered oil and 30% of its untapped natural gas. This potential wealth is drawing not only Arctic nations, but also global powers eager to secure future energy supplies. The rush to exploit these resources is already causing friction. Environmental groups warn of catastrophic spills, while indigenous communities fight to protect their lands and livelihoods. In 2020, a major oil spill in Norilsk, Russia, highlighted the dangers of industrial activity in fragile polar environments. The Arctic's transformation is attracting attention from far beyond the region. China, for instance, has declared itself a near-Arctic state and is investing heavily in polar research, infrastructure and shipping. The Polar Silk Road initiative aims to integrate Arctic routes into China's Belt and Road strategy, linking Asia, Europe and North America. China's ambitions have sparked concern among Western nations. In 2018, China attempted to purchase a large mining project in Greenland, raising alarms in Denmark and the United States about strategic control over critical minerals. In 2024, Norway blocked the sale of the last privately owned parcel of land in Svalbard to a Chinese buyer, citing national security risks, a move that underscored the growing suspicion and rivalry in the region. Svalbard, governed by a unique international treaty, has become a microcosm of Arctic tensions. The archipelago's open access provisions are being tested as nations vie for influence, and the Norwegian government's intervention in land sales is just one example of the high-stakes maneuvering underway. According to Dr. Elizabeth Buchanan, a leading Arctic policy scholar, the Arctic is no longer a zone of exceptionalism. It's a front line in the global contest for resources, influence, and security. The region's future will be shaped by a complex interplay of diplomacy, competition, and potentially conflict. Russia's military resurgence is matched by increased US activity. Joint military drills, intelligence operations, and surveillance flights are now routine. The risk of miscalculation or accidental confrontation is rising, especially as more actors enter the fray. NATO has declared the Arctic a strategic priority, and European nations are investing in new capabilities to defend their interests. The once peaceful, frozen expanse is rapidly becoming a theatre of great power rivalry, with global consequences, but the geopolitical fallout of melting ice extends far beyond the Arctic. In a world where all the ice has melted, vast new territories would be exposed in Greenland and Antarctica. The Antarctic Treaty, which has preserved the southern continent for science and peace for over 60 years, would come under immense pressure as nations eye the continent's untapped resources. Experts warn that the collapse of the treaty could trigger a scramble for territory and minerals, with countries abandoning long-standing agreements in pursuit of economic gain. The risk of conflict would rise as overlapping claims and resource extraction projects spark disputes. Antarctica could become a new flashpoint, with military deployments, standoffs, and even armed clashes over strategic sites and resources. The lessons of the Arctic would be repeated on a far larger and more dangerous scale. The consequences of a melting planet would not be limited to state actors and resource competition. As sea levels rise and coastal regions flood, hundreds of millions of people could be displaced, triggering mass migrations on an unprecedented scale. According to the International Organization for Migration, up to 280 million people could become climate refugees by 2100, straining international relations and fueling new conflicts over land, water, and resources. The influx of migrants would test the resilience of governments and international institutions, leading to political upheaval, the rise of nationalist movements, and, in some cases, violent clashes. The geopolitics of a melting planet would be defined not only by state competition, but by the movement and survival of people. The end of the Ice Age would not bring peace or prosperity for all. Instead, it would open a new and perilous chapter in global power struggles, resource conflicts, and human migration, one that will test the limits of diplomacy, cooperation, and our collective ability to adapt to a rapidly changing world. Beneath the vast, gleaming expanses of Antarctica and Greenland, a world of astonishing mystery and complexity lies hidden, one that, even in the age of satellites and supercomputers, remains largely unexplored. These immense ice sheets, some over 4 kilometers thick, act as a frozen shroud, concealing ancient secrets and landscapes that have not seen sunlight for millions of years. For scientists, these buried realms represent one of the final frontiers on Earth, a place where the past, present, and future of our planet converge in silence and darkness. Over decades, teams of researchers have deployed ice-penetrating radar, bouncing signals deep through the ice to map the contours of the land below. These efforts have revealed a hidden topography of breathtaking scale, a continent sculpted by ancient forces, with features as dramatic as any on the surface. Contrary to what one might imagine, Antarctica is not a flat, featureless plain beneath its icy armor. Instead, it is a land of towering, jagged mountain ranges, some rivaling the Alps in height, interspersed with deep, plunging valleys and vast plateaus. These mountains, long hidden from view, are remnants of a time when Antarctica was part of the ancient supercontinent Gondwana, their peaks now entombed in perpetual winter. Among these features lies the Denman Glacier Trench, the deepest land canyon on Earth, plunging an astonishing 3.5 kilometers below sea level. This immense chasm, carved by ancient rivers and glaciers, is so deep that if the ice were to vanish, it would form a vast flooded fjord, reshaping the coastline of Antarctica. But the wonders beneath the ice do not end with mountains and canyons. Hidden in the darkness are hundreds of subglacial lakes, liquid water bodies sealed off from the surface for unimaginable spans of time. Over 675 of these lakes have been identified in Antarctica alone, their waters kept from freezing by the crushing pressure of the overlying ice and the gentle warmth of geothermal heat rising from the planet's interior. These lakes are like natural laboratories, offering a glimpse into conditions that may resemble those on icy moons elsewhere in the solar system. Some of these lakes, such as Lake Vostok, have been isolated for millions of years, cut off from the atmosphere and sunlight. In these pitch-black, high-pressure environments, scientists speculate that unique forms of microbial life may have evolved, adapted to survive in total darkness, extreme cold, and complete isolation. The discovery of such life would not only expand our understanding of biology on Earth, but could also inform the search for life on other worlds. West Antarctica, meanwhile, is a region of hidden fire as well as ice. Beneath its frozen surface, scientists have identified 138 volcanoes, making it one of the most volcanically active regions on the planet, though almost all of this activity is concealed beneath kilometers of ice. Should one of these volcanoes erupt, the heat could melt vast quantities of ice from below, unleashing torrents of meltwater and potentially accelerating the collapse of the ice sheet. Such events have occurred in the past, leaving behind ash layers and meltwater channels as evidence of their power. Greenland, too, guards its own ancient mysteries beneath its icy dome. There, radar surveys have revealed a rugged landscape of mountains, valleys, and a colossal canyon that stretches for over 750 kilometers, longer than the Grand Canyon itself. This hidden gorge, carved by ancient rivers before the Ice Age, is a testament to the dynamic history of the land. At least 60 small subglacial lakes have been found beneath Greenland's ice, each a potential time capsule of ancient water, sediments, and perhaps even life forms that have persisted in isolation for millennia. If all the ice were to melt, these lost landscapes, mountains, valleys, canyons, and lakes, would be revealed to the world for the first time in millions of years. Sunlight would touch ground that has lain in darkness since before the dawn of humanity, awakening a new era of exploration and discovery. Rivers would begin to carve fresh paths through ancient valleys, their waters nourishing the bare rock and soil. Hardy pioneer plants, mosses, lichens, and grasses would be the first to take root, slowly transforming the barren landscape into a patchwork of green. Over centuries, these new lands would blossom into vibrant ecosystems, teeming with life. Forests could take hold, animals would return, and a new continent's worth of habitats would emerge, each shaped by the unique history and geology of the land beneath the ice. Yet, the melting of this frozen ground would also release things long trapped in the permafrost, remnants of ancient worlds preserved in the cold for tens of thousands, even millions of years. Among these are ancient microbes and viruses, some of which have not been active since the last ice age. Scientists have already revived bacteria from ice cores tens of thousands of years old, raising questions about what else might be lurking in the deep freeze, organisms that could offer clues to the origins of life or pose new challenges to modern ecosystems. While the risk of a global pandemic from these ancient pathogens is considered low, the possibility remains an unknown variable, one that underscores the need for careful scientific study as the ice retreats. In essence, the melting ice would open a geological and biological time capsule, offering scientists a once-in-a-lifetime opportunity to study the history of our planet, locked away in layers of ice, rock, and ancient life. We would uncover not only new landscapes and resources, but also the preserved remains of ancient forests, long-extinct animals, and perhaps even microorganisms that predate the rise of humanity. Each discovery would be a window into Earth's distant past, a chance to unravel the mysteries of lost worlds and to witness firsthand the profound power of nature's cycles of change and renewal. When we imagine a world where every last bit of Earth's ice has melted, the scenario is both staggering and sobering. But just how likely is it that our planet will ever become completely ice-free? To answer this, we need to dive deep into the science, examining climate models, future emissions scenarios, and the long-term fate of Earth's vast ice reserves. First, it's important to understand the sheer scale of the challenge. The total volume of ice on Earth is immense, with the Antarctic ice sheet alone holding over 26 million cubic kilometers of frozen water. The East Antarctic ice sheet, in particular, is the largest and coldest and has remained relatively stable for millions of years. This stability acts as a formidable buffer against rapid total melting. According to current scientific consensus, a complete melt of all Earth's ice is considered extremely unlikely within any timescale relevant to human civilization. Even under the most extreme warming scenarios projected by climate models, the process would take thousands, if not tens of thousands, of years. The reason lies in the physics of ice and the climate system. As ice melts, it absorbs vast amounts of heat, slowing further temperature increases, a phenomenon known as the ice albedo feedback. However, this does not mean we are immune to the consequences of melting ice. Human activity has already warmed the planet by about 1.1 degrees Celsius since pre-industrial times, and the effects are visible in the accelerating retreat of glaciers and the shrinking of Arctic sea ice. Climate models, such as those used by the Intergovernmental Panel on Climate Change, IPCC, project a range of possible futures depending on how much greenhouse gas humanity emits in the coming decades. If emissions continue at a high rate, what scientists call the business-as-usual scenario, global average temperatures could rise by 3.3 to 5.7 degrees Celsius by the year 2100. This level of warming would not melt all the ice immediately, but it would set in motion processes that are difficult, if not impossible, to reverse. For example, the Greenland and West Antarctic ice sheets are particularly vulnerable. Sustained warming of just 2 to 3 degrees Celsius could trigger their near-complete and irreversible loss over the next several centuries to millennia. The consequences of losing just these two ice sheets would be profound. Sea levels would rise by at least 13 meters, inundating hundreds of coastal cities and displacing hundreds of millions of people. While this is far less than the 71-meter rise from a total melt, it would still be a catastrophe for global civilization, fundamentally reshaping coastlines and economies. Scientific models use a variety of approaches to estimate these risks. Some models project that the tipping point for Greenland's collapse could be crossed within this century if emissions are not curbed, potentially leading to a complete melt-off by the year 3000. The West Antarctic ice sheet, already showing signs of instability, could also be lost within a similar time frame if warming continues unchecked. The greatest uncertainty lies with the East Antarctic ice sheet. For decades, it was considered almost impervious to climate change due to its size and cold temperatures. However, recent research suggests that parts of it may be more vulnerable to rapid warming and ocean-driven melting than previously thought. If certain thresholds are crossed, even this giant could begin to lose mass, though this would likely unfold over many thousands of years. It's crucial to recognize that the fate of Earth's ice is not predetermined. The future will be shaped by the choices humanity makes today about energy, land use, and our relationship with the natural world. Aggressive action to reduce greenhouse gas emissions, transition to renewable energy, and protect natural carbon sinks can slow or even halt the most dangerous changes. In summary, while a total melt of all Earth's ice is a scenario that would take many millennia, the risks posed by partial melting in the coming centuries are immediate and severe. The ice sheets are not just passive victims of climate change, they are active players in the Earth's climate system, and their fate is intertwined with our own. The ice is a silent, waiting giant. Its future and ours hangs in the balance, determined by the scientific realities of climate change and the collective decisions we make as a global society. If all of Earth's ice were to melt, the world wouldn't just look different, it would feel different too. The disappearance of the planet's frozen reservoirs would set off a cascade of changes in global weather patterns, fundamentally altering the climate as we know it. First, consider the oceans. Today, the polar ice caps play a crucial role in driving ocean currents through a process called thermohaline circulation. This global conveyor belt moves warm, salty water from the tropics to the poles, where it cools and sinks, helping to regulate the planet's temperature. But with no ice left to cool and freshen the surface waters, this circulation would slow dramatically or even stop. The result? entire regions could see their climates shift overnight. For example, Western Europe, currently warmed by the Gulf Stream, could plunge into a much cooler, stormier state, even as global temperatures rise. Without the reflective power of ice, known as albedo, Earth would absorb far more solar energy. This added heat would supercharge atmospheric circulation, intensifying wind patterns and altering the familiar paths of jet streams. Storm tracks would shift, bringing droughts to some regions and relentless rains to others. Monsoon systems could become more erratic, threatening food security for billions. The loss of ice would also mean the end of the polar vortex as we know it. Today, this swirling mass of cold air is anchored by the icy Arctic. Without that anchor, the vortex would become unstable, increasing the likelihood of extreme weather events. Think blistering heat waves, sudden cold snaps, and more frequent powerful storms. Sea level rise from total ice melt would also reshape coastlines, changing the distribution of land and sea. This new geography would disrupt established wind patterns, creating unfamiliar weather in places that have been stable for centuries. In short, a world without ice would be a world of extremes. Heat waves would be hotter, storms fiercer, and droughts longer. Ocean currents would falter, and the very rhythm of the seasons could change. These are not just theoretical shifts, they're the logical outcome of removing one of Earth's most important climate regulators. Scientists warn that while a total melt is unlikely in our lifetimes, even partial loss of ice is already beginning to reshape weather patterns across the globe. The message is clear. The fate of the ice isn't just about rising seas, it's about the stability of the world's climate and the weather each of us experiences every day. As the planet's ice disappears, the changes ripple far beyond weather and coastlines, reaching deep into the heart of our oceans. The marine world, shaped for millennia by the ebb and flow of ice, would be thrust into unprecedented upheaval. First, consider the habitats that rely on ice. Polar bears and seals are the most visible victims, but beneath the surface, entire communities depend on the seasonal rhythm of ice formation and melt. Algae grow on the underside of sea ice, forming the base of a food web that supports krill, fish, and ultimately whales and sea birds. Without ice, this foundation would crumble, threatening the survival of countless species. As temperatures rise, species adapted to the cold will be forced to migrate, if they can. Some may journey poleward in search of suitable conditions, but for others, like the Antarctic icefish, there is simply nowhere left to go. This mass migration would redraw the map of marine biodiversity, introducing new competitors and predators to once stable ecosystems. The loss of ice also means warmer, fresher surface waters, which can disrupt nutrient cycles. Today, melting ice helps drive ocean mixing, bringing nutrients up from the deep. Without it, these life-sustaining nutrients could become trapped below, starving phytoplankton, the microscopic plants that form the basis of the marine food chain. A decline in phytoplankton would echo up the food web, reducing fish stocks and threatening global fisheries. Coral reefs, already stressed by warming and acidification, would face even greater challenges as ocean chemistry shifts and storm frequency increases. The combined pressures could push many species to extinction, unraveling the intricate tapestry of life in the sea. In the end, the melting of Earth's ice is not just a story of rising seas and changing weather. It is a story of profound transformation in the world's oceans, of habitats lost, species on the move, and food webs in flux. As we contemplate the future, the fate of marine life serves as a stark reminder. The consequences of a melting planet reach every corner of the Earth, above and below the waves. For thousands of years, ice has been more than just a force of nature. It has been a source of wonder, fear, and inspiration for human societies across the globe. Long before satellites tracked shrinking glaciers, ancient peoples looked to the frozen expanses and wove them into their myths and legends. In the far north, the Inuit told tales of Sedna, the goddess who ruled over sea mammals and icy waters, her power shaping both the bounty and peril of the Arctic. In Norse mythology, the world itself was born from the primordial ice of Niflheim, where fire met frost and creation began. Even in the Himalayas, ice-clad peaks became sacred, revered as the abodes of gods and the source of life-giving rivers. Ice has also been a silent architect of civilizations. It carved out valleys that became fertile farmlands, shaped migration routes, and set the boundaries for empires. The famed Silk Road once skirted the edges of glaciers, and entire cities depended on glacial melt for drinking water. In more recent history, the quest for the Northwest Passage, an ice-choked sea route, drove explorers to risk their lives in search of new worlds and fortunes. Yet ice is not only a symbol of endurance and danger. For many cultures, it represents purity, transformation, and renewal. Winter festivals celebrate the first snowfall, ice sculptures rise in city squares, and stories are passed down of winters so harsh they tested the very fabric of communities. As the ice melts, we risk not only losing unique ecosystems, but also vital threads of our shared heritage. The legends, rituals, and histories born from these frozen places are at risk of fading into memory, just as the ice itself retreats. In confronting a world without ice, we are also faced with the challenge of preserving the stories and wisdom that have shaped humanity's relationship with the coldest corners of our planet. As the last glaciers vanish and polar ice caps become memories, humanity is thrust into a new era of technological innovation and unprecedented engineering challenges. Without the natural barriers and resources that ice once provided, our very way of life will require radical adaptation. Coastal cities, no longer protected by polar ice, will race to build towering sea walls and deploy floating neighborhoods to withstand relentless sea level rise. Engineers will pioneer adaptive architecture, structures that rise and fall with the tides, or even entire cities designed to migrate inland as shorelines retreat. In agriculture, the loss of glacial meltwater will force farmers to turn to advanced desalination plants and precision irrigation systems powered by renewable energy. Vertical farms and climate-controlled greenhouses could become the norm, growing crops in regions once too cold or too dry to support life. The melting of permafrost will expose vast tracts of land, but also unleash ancient microbes and destabilize existing infrastructure. Scientists and engineers will collaborate to develop biohazard containment protocols and design buildings with flexible foundations that can withstand shifting soils. Meanwhile, in regions once locked in ice, a new frontier opens for resource extraction. Undersea mining robots and automated drilling platforms will tap into mineral reserves beneath the thawed Arctic seabed. This technological gold rush will demand robust international oversight to balance economic opportunity with environmental stewardship. Water scarcity will become a defining challenge. Mega-scale water transport systems, vast pipelines, and artificial rivers may be constructed to reroute water from flood-prone areas to parched cities. And as traditional energy sources are disrupted, the world will look skyward, harnessing solar and wind power on an unprecedented scale. Floating solar farms and airborne wind turbines could become common sights where once only icebergs drifted. Yet, every innovation will come with hard choices. The race to adapt will test our ingenuity, ethics, and global cooperation. In the absence of ice, humanity's resilience and creativity will shape the next chapter of our story, engineering a future on a transformed, unfrozen Earth. As the last traces of ice vanish from our planet, the transformation is not only physical, it is deeply psychological. For countless generations, ice has been more than just a feature of the landscape. It has shaped our myths, inspired our art, and stood as a symbol of endurance and purity. The glint of sunlight on fresh snow, the silent expanse of polar wilderness, these images have stirred something profound in the human soul. But in a world without ice, we face an unprecedented sense of loss. The disappearance of glaciers and polar caps is not just an environmental shift, it is the erasure of a shared cultural memory. For many, it will feel like losing a cherished home, a part of our collective identity slipping away with the meltwater. This loss will challenge us to redefine our relationship with nature. No longer can we see ourselves as mere observers of a wild, untamed world. Instead, we become its architects and caretakers, bearing the weight of responsibility for what remains and what has been lost. The landscapes we once revered for their permanence now remind us of nature's fragility and our own. Yet, in the face of this grief, the human spirit is resilient. Our capacity for adaptation will be tested not just in our technology but in our hearts and minds. New rituals will emerge honoring the memory of the ice and what it represented: endurance, transformation, and beauty in stillness. Artists, poets, and philosophers will grapple with the meaning of what is gone, and in doing so, help us find a new sense of belonging in a changed world. Ultimately, the melting of the ice compels us to ask, what does it mean to be human on a planet we have so profoundly altered? Can we forge a new harmony with a world in flux? Or will the echoes of loss shape our future as much as any physical change? In the end, the story of a world without ice is not just about adaptation. It is about rediscovering our place within nature and learning once again to find wonder in what endures.